Jai Hind to all of you. I am Dr. Himani Garg, working as professor in Department of Electronics and Communication Engineering at Ajay Garg Engineering College, Ghaziabad. Today I am going to discuss about handoff strategy, that is very important concept in wireless and mobile communication. My PPT will include the content of handoff, types of handoff, classification of handoff and strategies of handoff. Now, what is this handoff? This is a criteria that is used in cellular system in which an area is divided into cells and each cell is covered by a base station. So whenever a user moves from one cell to another cell, that means it comes under from one base station to another base station, then there should be handover of the call. If the user is in call, then that call should be transferred to the another base station. This term is called handover. So whenever a mobile moves into a different cell while conversation, we are talking about when the person is in conversation, the MSC. What is this MSC? This is mobile switching center. So many base stations are there. They are connected to a mobile switching center. It automatically transfers the call to a new channel belonging to the new base station in which the person is residing. That is called handoff. Now, handoff operation not only involves identifying a new base station. This is not that we have to identify the new base station, but as the user is on call, then the signals are voice and control signals are there. These signals should also be transferred to the new base station, be allocated to channels with the new base station. Now, the handoff must be performed successfully and as infrequently. So whenever we are on call and we are moving, then it should be performed, the handover is required to be performed successfully, otherwise the call will drop. And another thing is that it should be performed infrequently, otherwise if the handoff is frequent, then it will put a burden on the MSC, then the MSC will keep on working on the handoff stages. For this, system designer must specify an optimum signal level at which to initiate the handoff. As we know that whenever we are on a call, then we are connected with the base station. We are in a particular, we are having a particular range of signal with a particular base station. And if that signal level drops below a particular level, threshold level, only then the handoff should occur to the other base station. So it is very much required to study about this minimum power level that will initiate the handoff. Once a particular signal level is specified as the minimum usable signal for acceptable voice quality at the base station receiver, a slightly stronger signal level is used as threshold. So we are having two levels of signals. One is the minimum level of signal at which voice quality is acceptable. Another is another signal that is above that is called the threshold level. So that should be, we have to take the decision between these two levels that whether the handoff should occur or whether the handoff should not occur. So you can see this margin threshold is denoted by delta, that is power of the handoff minus minimum usable power. So we have considered a power at which handoff should occur and minus the minimum usable power at which the voice acceptable quality is acceptable. So we have to take decision on the basis of this delta. I will explain this with the help of this diagram. You can see here we are having two situations. One is improper handoff situation, another is proper handoff situation. Now this is the case, the scenario is this, in which we are having two cells and there are two base station 1 and base station 2, and there is a mobile user who is under the coverage of this base station 1, and the user is moving from A point to B point. You can see here A point is under the range of base station 1, whereas this B point is under the control of base station 2. So whenever the user is moving from A towards B, then at this point the MSC has to take decision whether he has to go for handoff or whether it has not to go for handoff. So the power level at point A and power level at point B will be measured at every point. You can see here, this is the situation of improper handoff, in which on the y-axis we are taken the received signal power of the mobile station. So this is the level at point A, this is the signal level at point A. Now as I had told you in the last slide, we are having two levels in between which the decision has to be taken for handoff. So one is the handoff threshold and another is the minimum acceptable signal to maintain the call. So the threshold level is taken at some higher level than this minimum value. This is the threshold and this is the minimum value. So the decision to go for the handoff is to be taken within this particular range, that is called delta. Now in this case, when the user is moving from station A to station B, this is the station A, and here you can see the level at station B. In between this region, the MSC has to take decision that there should be handoff or not. If the decision has not taken, the signal has gone below the minimum acceptable level and the decision has not been taken, then what will happen? At point B, no handoff has taken place, so the call will drop down. So, and in this case, you can see here, this is improper handoff in which the call will drop. Now, this is the situation for proper handoff. You can see here, the same situation is there. The user is moving from A, the signal level is A, and he is moving towards B, and this is the delta threshold level, and in between this, the signal level has dropped. Now, this is the signal level, is the level at which handoff is made, that is above the minimum acceptable level. This level is above the minimum acceptable level. The decision has been taken by the MSC to shift the transfer control from base station 1 to base station 2. So this case, you can see here, the signal power has again increased because at this point the handover has been taken by the MSC. So this is the case of proper handoff. The call has not dropped and the user who was already connected with base station 1, now he is in connection with the base station 2, and the call is on and the call has not dropped. So this is a case of proper handoff situation. So you can see from the same thing that I have told you in the last slide, that has been summarized here. So you can see delta. What is delta? Delta is the threshold, the difference between the threshold and the minimum acceptable level. Now the delta can't be too large or too small, because MSC has to continuously monitor the value of delta and he has to take decision. So the delta shouldn't be too large and it can't be too small. Now what will happen if we are considering the different cases of delta? Case 1, when the delta is too large. Now we consider that delta is too large. Unnecessary handoffs are there which burden the MSC. So if the delta is too large and we keep on, according to this delta, we are taking the decision that handoff should occur, then ultimately what will happen? There will be lots and lots of handovers will be there, and then if the number of handoffs will increase, then it will put a burden on the MSC. If case 2, if delta is too small, if we are taking the value of delta, this delta is too small, this delta is too small, then what will happen? There may be insufficient time to complete a handoff before a call is lost due to weak signal. If you are taking the delta value very small, then what will happen? The signal will keep on dropping, and then ultimately the call will drop and handoff has not, the base station has not got the proper time for handoff. Now, these are the two cases. Now we will see the call drop occurs due to two different reasons. One is call drop event can happen, case 1, when there is an excessive delay by the MSC in assigning a handoff. Because handoff is taken care by the MSC and we are saying that the call has dropped. That means call is dropped due to the reason of MSC. MSC has not taken the decision to take the to go for handoff. This is taking lot of time. This excessive delay, why this is excessive delay at the MSC end? The reason is high traffic density. If the MSC is dealing with so much traffic, then it will be difficult for MSC to take the decision for handoff. So high traffic density due to computational load at the MSC, that's why the handoff will not occur and the call will drop. Second case, due to the fact that no channels are available on any of the nearby base stations. Now MSC has to provide a channel to the another user who is coming for handoff, but if there is so much traffic is there and all of its channels of the MSC are used, then he will not be able to provide the channel to the user who is asking for handover. So that's why then also the call may drop. Now the second case, when the threshold delta is too small for the handoff time in the system. If the value of delta is too small, that handoff is not taking, MSC has no time to go for the handoff. So that's why the call will drop. Now this another term that is used during this handoff is dwell time. What is this dwell time? that time over which call can be maintained within a cell without handoff is called the dwell time after the handoff threshold. So you can see for the time during which the user is in particular cell before handoff, that is called the dwell time. Now we move on to the next thing, that is the types of handoff. You can see the handoffs can be intra-cell, intra-BSC, intra-cell and intra-BSC, inter-cell, intra-BSC handover, inter-cell, inter-BSC and inter-MSC handover. So the first one is intra-cell BSC. Intra-cell means within the particular cell. So this is a particular cell. Here we are having BTS and BSC. Now if a user is from given earlier he was working on an old channel and he has been provided with new channel. That means within a particular cell itself, the BSC has taken the decision to provide the new channel. So that means intra-cell, intra-BSC handover is there. Smallest of the handover is the intra-cell handover, where the subscriber is handled to another traffic, generally another frequency within the same base station. Inter-cell, intra-BSC. Inter-cell, intra-cell means there are two cells are there. Intra-BSC, the BSC is the same. Then this type of handover is called inter-cell, intra-BSC. Inter-cell, inter-BSC handover. Inter-cell is there, two cells are involved and two BSCs are involved. The subscriber moves from cell 1 to cell 2, which is served by another. If this cell is served by one BSC and this cell is served by another BSC, then the handover that will occur, that will be called inter-cell, inter-BSC. Defer connection with the first BSC and BTS is released when the connection with the new BSC, and obviously when the user is moving from this cell to another cell, the connections, all these earlier connection will be dropped and the new connection will be set up. Now inter-MSC, now we are saying that there are so many BTS are there, so many BSCs are there, MSC are there. If there is inter-MSC, number of different MSCs are there, two MSCs are involved. If two MSCs are involved in handover, then it is called inter-MSC handover. Traffic connection with the first BTS, BSC and MSC will be released when the connection with the new BTS, BSC and MSC is set. So this is inter-MSC. Now this is according to this handover was according to the MSCs and BSCs involved. Now we will talk about the another type classification of handoff, that is on the basis of hard handoff and on the making of connection and breaking of connection. That is hard handoff and soft handoff. How the connection is made and how the connection is broken. So hard handoff means also known as break before make. Do remember this thing. Hard handoff means you have to just first break the connection and then make the connection. Break before make. As shown here, it is one in which the channel in the source cell is released and only is engaged. Means the cell in which we are here, this connection is broken with this, and then the connection with the next cell is breaking of the channel, and then you will be providing with the new channel. Thus the connection to the source is broken before the connection to the target is made. Connection to the source is broken, connection to the target is made. Hard handoffs are intended to be instantaneous. If it is not hard instantaneous, then you will be able to listen. There will be some call drop can be there, or there can be other noises can be there. Intended to be instantaneous in order to minimize the disruption to the call. It is not necessary that there is always a connection between base station and the mobile station. That means if we are saying that there is a break of the connection, that means we are not connected with the base station at that particular time. Another is the soft handoff, also known as make before break. So this is the better thing rather than the break before make, because in that there may be there are the chances that our call is disrupted. But in this, you are handing over the call. One base station is handing over the call to the another base station, because the connection with one base station is there until the connection with the second base station has been made. So it is make before break. It is one in which the channel in the source cell is retained and used for a while in parallel with the channel in target cell. Thus the connection to the target is established before the connection to the source is broken. there is always a connection. In this case, you can see we are always connected with one base station. There will be always connection between the base station and the mobile station. Now, what are the different strategies that are used for handoff? Means how the handoff will occur, which strategies will be followed for making this handoff. These are the handoff can be network assisted handoff or it can be mobile assisted handoff. Now, as we know in handoff, the power of the signal is checked. Now, this power of the signal, whether it drops below a certain level, how it will be monitored? It can be monitored by the network or it can be monitored by the mobile. If it is monitored by network, then it is called network assisted handoff, and if it is monitored by mobile station and then handover will occur, then it is called mobile assisted. So, network assisted handoff, that was used in 1G analog system. In this handoff, base station continuously monitors the signal strength of each mobile user and report to the MSC, which makes the decision. Ultimately, the decision maker is MSC, but here, who is monitoring the mobile station? Base station. Base station is continuously sending some signal to the nearest mobile stations and checking their signal strength. If the signal strength of a particular mobile station goes below a particular level, then he will provide information to the MSC that this mobile station is not within my range, it has moved to some another location. Then accordingly, the network will take decision that how the handoff will occur. In addition to measuring the RSSI, radio signal strength measurement of the calls is in progress within the cell, a spare receiver in each channel station called locator receiver. Now, how it is done? Whenever we are making a call, we are on a call, then along with call, another control channel is there that is continuously in contact with the base station. Base station is in contact with us, that will be taking care of location receiver, who will be providing us, who will be taking the idea of our location to scan and determine the signal strength of the mobile user which are in neighboring cells. The locator receiver is controlled by the MSC and is used to monitor the signal strength of the users in neighboring cell which appear to be in the need of handoff. So, he will be keep on monitoring the cells, the mobile stations which are close to that particular cell, and if they require a handoff, then accordingly the network will provide the handoff. So, that is why it is called network assisted handoff. Mobile assisted, that we all use, our mobile antennas are there, we are having a mobile station with us, and our mobile station is continuously in contact with the nearest base stations from which they are getting the maximum power. So, whenever we are on call, and we are moving, then the nearest base station from which we are getting the maximum signal, we will be connected to that particular base station, and in this case, when the handoff will occur, that handoff will be called mobile assisted handoff. In this handoff, every mobile station measures the received power from surrounding base station and continuously reports the result to the serving base station. A handoff is initiated when the power received from a base station of the neighboring cell begin to exceed. So, the power of the nearest base station begin to exceed the power received from the current base station by the certain level for a certain period of time. This is called MAO. In method enables the calls to be handed over between the base station at a much faster rate than the 1G. Since handoff measurements are made by each mobile and the MSC no longer constantly monitors the signal strength, that will reduce the burden on the MSC, because now MSC is not involved in continuously monitoring each and every mobile station. Mobile station is in itself is monitoring the nearest base station from which it is getting the maximum power. MAO is particularly suited for micro cell environment where handoffs are more frequent, where they can monitor the power of the signal. Another thing is prioritizing of handoff or guard band concept. As we know, for whenever a user is moving from one cell to another cell, each cell has been assigned a particular set of frequencies. So, whenever the user has to move from one cell to another cell, then another cell should be able to provide the frequency for handover. So, in this case, every cell will keep a set of frequencies. He will be keeping some set of frequencies that will be used for handover. Rather than providing that frequencies to the users within that cell, he will be providing that frequencies to the visitors or another persons who will be coming to their cell as for handoff purpose. So, that is called the guard channel. Another is here some of the channels of the total available channel is reserved for handoff request from ongoing call which may be handed off into the cell. Guard channel, however, offer efficient spectrum utilization when dynamic channel assignment strategies are used, which minimize the number of required guard channels by efficient demand-based allocation. Because they will be, when the spectrum is being divided, then some of the spectrum will be kept for guard band channels. Another is the queuing of handoff request. Now, in another method to decrease the probability of forced call termination due to lack of available channel, queuing of handoff is possible due to the fact that there is a finite interval between the user who is asking for handoff. He will be kept in queue until the handoff will occur. So it's not that the second cell in which we are moving, he is not having any frequency. He will definitely say that I am not having any frequency. He will be keeping that user in queue unless the handover until the handover procedure has taken place. So this is about prioritizing handoff and queuing. These are the set of references that I have followed. I hope you must have understood the concept of handoff. Thank you for listening.